speaker is the illustrious James Starnes. He's the Surface Geology Director at Mississippi Department of Environmental Quality with expertise in geological mapping, paleontology, cultural resource management, and environmental awareness. And his lecture is on the geology of the Pearl River. So thank you, James.
Appreciate everybody coming today. This is the little clicker here. Let me see if it works. Yes, it does. Awesome. We'll click back. There it goes. All right. Glad everybody's here today. Get away from this microphone. I'm with the State Geological Survey. We've been around since 1850. We're one of the oldest surveys in the country. We predate the United States Geological Survey by a number of years. It was within our state legislature many, many moons ago, understanding that the geology was the basis of the environment, and understanding our geological resources, helps us to utilize our environment as well as protect our resources. All right. The Pearl River. Who knows why the Pearl River is called the Pearl River? I do have a giveaway today. Why is the Pearl River called the Pearl River? Yes, sir.
Because of the mussel shells.
That's correct. And you get a Oligocene fossil, which I'll demonstrate a little bit later today. All right. Absolutely. All right. Our focus has been primarily on geological mapping. This is our 1860 Hill Guard map, and you can see our ideas about our geology have changed over time. The more data we get, the more fossil locales, the more outcrops we visit, the more drill holes that we get data from, changes our idea as far as the geology of the state and how it's all put together. Now, the rivers are very, very important to us as geologists for a number of reasons. Number one, when we go out and we're looking at outcrops and things like that, it's not like driving out west where you're like, oh, geology everywhere. Well, geology is everywhere here too, but it's buried under grass and trees and things like that. And so to get that window into, into the past and our window into the geology where we actually see these things, our drainage systems provide that opportunity for us to actually get out there and see the geology firsthand. All right, we've been focused primarily on 7.5 minute geological mapping. That's really, really, really detailed geological mapping. And on this 7.5 minute scale, this is kind of where we're at as far as a reconstruction of the state geological map, which hopefully will come out here the next year. It doesn't look like there's a whole lot that's been done, but we're focusing on areas that we know are problem issues. And the Pearl River drainage is one of those problem issues as far as our understanding of the geology. And I'll get into that a little bit here in a minute. We have a failing 1500, so we can actually go out and get our own, boreholes. We can actually look down into the earth with this drill rig. Most surveys don't have that capability, and that allows us to get information where we don't have information available to us. All right, here's our national watershed. So that's our watershed map. You can see the mighty Mississippi, is part of our watersheds there. And you can see Mississippi down over there with our other minor basins. I'll get into that. And here's our Mississippi watershed map. The colors are a little different than the other map. There we go. All right, so you can see that the drainages actually reflect the geology. These drainages, the divides as far as the drainages are associated with the outcrop geological patterns there. All right, here's the physiographic map and the ecoregions map. You can still see that both of them are reflective of the geology and the geological outcrops. And here's our Pearl River coming through here. And this is some hillshade LiDAR map. And then here is the EPA ecoregions. And they're both reflective of the geology. All right, so our rivers haven't always been here. So let's go back to some of our oldest geology. Our oldest geology is actually up in northeast Mississippi. Let's go back to the Cretaceous period when Mississippi was completely covered with ocean. And so we have no rivers at that time. And this is going back some 66 million years ago. There we go. All right. So what happens is as sea levels fall, this is actually two pictures that I took on the Pearl River, one of the sandbars out here, after they dropped the level of the river below the spillway. And I love to get out and take pictures of sand because, water and its action on this earth is the same at any scale. So these same processes that you see in this microcosm on this back of the sandbar can be brought out to much larger things. All right, so right here kind of shows where sea level was at one time. This was the water line at one time, and as the water falls or sea levels fall, the streams start to in size and build deltas out landward, and then what they start to do is they start to build dendritic drainages up into the uplands, and so that kind of demonstrates that there. All right, there's Chaco Canyon. It was a good diagram. We're not in Chaco Canyon, obviously, but again, the same principles still apply throughout our these geological processes with water. And as a stream cuts down and builds a migrating type system, a meandering type system, it moves sediment back and forth. It creates a Yazoo channel, see a Yazoo tributary, which actually got named for streams here in Mississippi. That is a stream that's occupying a floodplain of a modern stream. You can see all the different environments of an incising stream. And eventually the streams get choked with sediment, and this is exactly how complicated these systems are. These are all microenvironments within this system. Is it gonna? There it is. Oops, it's going too fast. All right, showing you how complicated these alluvial systems can be. This is off the Mississippi River. This is actually where we're mapping over near Money, Mississippi, and this is kind of the geological interpretation, but this is exactly how complicated these microcosms in these streams, including the Pearl River, can be. And just showing you how complicated that is with the LiDAR shot on the left side there. All right, come on. Oops, I know it's going to go too. All right, so how long ago did the Pearl River form? Well, the last time the seas covered this area was the Oligocene, some 30 million years ago. Okay, so chances are it's sometime around the Oligocene. I think I got what choked. There we go. There's the Oligocene. And so and here it is. Here's the Oligocene right here. This is the Vicksburg limestone that sits just south of the Jackson Prairie here. And that's the last time that much of Mississippi was actually covered in ocean. So the Pearl River probably is no older than that. Well, it's actually probably just a little bit younger than that based on what it cuts through. And here, is it going to go? Probably during the Pliocene. And it really has to do with the Pearl River actually cuts two terraces. You can see it on the map over here. What used to be the Citronelle Formation, we've actually divided up into two different alluvial systems from rivers that crossed the coastal plain a long time ago that weren't the Pearl River. And these are going to be ancestral Tennessee-Ohio system that covered south of Mississippi and drained the mid-continent prior to glaciation. And there's the McGee Airport Terrace, which we're mapping, and the Brookhaven Terrace at 540 to 560, and then 490 to 520 on the east side. All right? Let's see if this will do it. Trying to get it to change. All right, okay, I'll talk about this slide a little bit more. All right, how we know these river systems did exist through here, that's actually behind the Mexican restaurant there in McGee. That's red sand and gravel. That used to be an old fluvial system that was the bottom of a river channel that is sitting 400 feet above sea level, modern sea level today. All right, North America during the last glacial maxima 20,000 years ago, okay? Well, that system, that ancestral Tennessee-Ohio system, worked its way to the west to where the modern Mississippi River is today during the ice ages. And during this time, this was kind of a different climate. We were more of a temperate and deciduous forest at this time, but the Pearl River definitely did exist at least during the Pleistocene. We know that. And when sea levels fell some 20,000 years ago, they were 400 feet lower than they are today, and that exposed a lot of the shelf. And what it did, it allowed the coastal rivers actually to incise a deeper channel. So head cuts went up these rivers and expanded their territory up into the uplands. And we also see the response in the Lower Pearl from our current geological mapping. This is an area that's going to be published here in June of a complete geology of the coast. And you can see that these cycles of terraces are from rises and falls of sea level during the Ice Age. But not only that, you can also see that the Pearl River once went into Bay St. Louis over here. So Bay St. Louis is actually an old mouth of the Pearl, and it was blocked by a barrier bar sequence through here. So these environments have actually changed quite a bit over time. And I still need that to... There we go. All right, so here's the barrier bar that we know that's underneath New Orleans, and here's a fossil site on Long Beach. And this geological mapping, we can see that the Pearl once made a kind of a dog leg through here as it was blocked by this barrier bar sequence. And here are the fossils that we collected this past summer, from this old barrier bar system here at Long Beach. All right, well, we use artifacts just like we do fossils when we study these fluvial systems. And right here, here's a Clovis point, actually 2 Clovis points. Well, a total of actually 4 Clovis points have come from near the confluence of the Strong River and the Pearl River. And that's how we know the age of some of these landforms within this system. And so the archaeological record is actually very, very important for us when we're looking at these river systems to kind of understand exactly how old these systems are, their evolution over time. And these archaeological sites are a good window, just like fossils are a good window into the rest of the geology. All right, people have been modifying the Pearl River for a long, long time. This is an archaic mound system where they've gone and actually dug out some of the old channel to make a moat. And this mound complex, this is actually sitting on the lower part of the Pearl on one of our WMAs. We went to go check this mound site out, and this is about a 5,000-year-old mound complex down there. All right. People have been modifying it throughout historical times too. We've got this came from Monticello, and this was actually found by one of our wildlife fisheries and parks officers during alligator season. And they found this old boat sticking out, and this is likely from the old logging industry, going back when they were pushing log jams down the Pearl River many, many moons ago. And we actually were able to preserve this boat, and it's set up on Turcotte for a little while we got everything as far as the restoration tank. And Georgia Pacific is the one who actually spent the time and energy to have this thing restored, and it's on display at the museum down in Monticello. All right, the geology in the Pearl River, the geology that the Pearl River traverses. Each geological unit creates a unique set of substrates, contributions to the bed load, geochemistry, and hydrodynamics of the river. The river is a culmination of the sum of its tributaries, and therefore the natural ecology and human and land water use affects parts of the watershed differently. So what geology does it cross? Back to the physiographic map here. We've got the North Hills area, which is dominated by sand, silts, and clays of the Wilcox and the Claiborne group. We've got We've got the Jackson Prairie, where we are now, and I'll get to talk about that here in a minute. And it covers also the Southern Pine Hills as it goes through South Mississippi, and it also goes through our coastal deposits. And here is our state geological map there to kind of compare. All right, so the very, very upper reaches of the Pearl River system cuts through a series of unconsolidated sands and clays and alternating sandstones and claystones. This is of the Wilcox over here, and this is of the Tallahatta over there. These pictures were taken at fresh outcrops and mined areas outside of the Pearl River drainage, but this is just kind of demonstrating that the geology continues across the Pearl. But this is what the river cuts throughout much of the upper portion before you get to the Jackson Prairie. And these are fairly acidic. There's not a whole lot of carbonate associated with this, so it's going to affect the water. It's also going to affect the bed load, but it's also going to affect the substrate within the river itself. So at this point, there's no gravel available to the river system at all. All right, as we come out of the Claiborne and into the Jackson Prairie, that's about where the Ross Barnett starts. This is one of our more recent maps that we produced for the National Park Service. And you can see that the valley's pretty well flooded there through the upper part. There's the Pearl River WMA, which I spend most of my winters at. But kind of showing you what the geology is as it comes across the prairie here. All right, and as we get to this area where we're standing now, this is just upstream of us here at the at the dam of Ross Barnett. Here's the Ridgeland geological quadrangle, which we produced also for the Park Service, and it is kind of a unique system when the Pearl River crosses the Jackson Prairie. This is an area that is not really well developed. The Jackson Prairie itself is, in the uplands, are well developed and have been for agriculture for, since the settlement of this area. But the Pearl River floodplain has been left alone other than logging. It really has to do with the dynamics of the system as this river crosses the prairie. And as it crosses the prairie, it crosses the Yazoo Clay and the other Jackson Group formations. It is a heavily dissected floodplain, and it makes it very, very difficult to develop. So that was how this area behind the museum here has been kept so pristine over time. It really has to do with how difficult and how complicated that system is. And I really wish you could kind of see there, but you can see how well this is a deeply dissected floodplain that goes across through here. And it's a beautiful ecological resource. And it really has to do with the fact it's been left so pristine. Has to do with, as it crosses the Jackson Prairie here. Also, the Jackson Prairie is very, very important to us as far as paleontology. This is where we get our fossil whales, our state fossil. This one was collected out of the Scott County landfill, and the reconstruction there is the one that's hanging downstairs. That was some of my earliest paleontological work working for the survey back in 2005. But during the building of the dam there at Ross Barnett, one of these nearly complete skeletons had come across. And our survey had come out to look at it, but there was no money at the time to actually excavate it, so it all ended up in souvenirs. We've been trying to get pieces and parts back for years, but these are the kind of things that can be found, in the banks of the Pearl, but not only that, the Pearl River drainage itself as it crosses the prairie. All right, the fossils that the Pearl River contains and its tributaries contain are very, very important to scientists for a lot of reasons, because a lot of this is original shell material from these marine fossils dating back some 40 million years ago. And we use these things like ice cores. There are things that are locked in there as far as the chemical signatures of the ocean water and the climate at the time. And so this is one of the unique places. The prairie offers one of these unique places where we can find these types of well-preserved fossils. That thing's 40 million years old, and it's still the original shell material. And from that, these are little bitty drill holes that went all around there. And then here's what we can reconstruct as far as the paleoclimate. So these fossil resources coming out of the Pearl River drainage are incredibly important to us as scientists. Well, also, one of our few really neat geological features is the Jackson volcano, which sits directly beneath us here. Okay, and we actually crossed through geology that the river crossed through previously further upstream. It goes over it again as it has risen because of the effects of the Jackson Dome. So the formations that you see literally in the golf course over here, you don't see again until you're further upstream, up north of Canton. These are some of the seashells that we collected out of Town Creek, just around the corner, and these are some of the neat fossils from the Eocene. But not only that, this is some I picked up off a gravel bar after fishing this past summer, and that is a stingray barb from all those marine creatures that were living in what we call the Jackson Sea, which is the Jackson Prairie. Now we go a little bit further to the south, things get a little more rocky. Actually, this is the first really rock we kind of run into as far as the drainage of the Pearl. And this is overlooking the bridge there at Byram, if anybody's familiar with the Byram Swinging Bridge. But it's also famous for its fossil content. That is the type locality of the Byram Formation. That little sand dollar that I passed out a minute ago, that right there is from the Oligocene period, so some 30 million years ago. And this is where the Pearl River really starts to change. Okay, coming through this rocky type unit just south of the prairie. All right, and then it continues to get rocky as you cover into the Catahoula Formation. And the Catahoula Formation on the Pearl runs between here and just south of the Strong River. And there's one of the water parks there on the tributaries of the Pearl. You can see the Catahoula sandstone. So the substrates change, but also in the uplands are being stripped of the gravels that I was talking about earlier, those little graveliferous terraces that the river kind of cuts through there, and it adds a bed load of this gravel. This gravel doesn't occur anywhere north of this, and so all of a sudden things are actually coarsening as we go downstream, and we've got these wonderful, huge gravel bars. And this is part of a mussel survey I got out with our folks here at Fisheries and Parks. Also, the famous Red Bluff. This is over in Marion County, and this is showing you how steep the terrain is and the drainage of the Pearl. It's how pretty it is. And that's just active erosion. Of course, that material is going to end up as bedload of the Pearl River eventually. All right, and this is getting a little bit further south, and this is getting into the Pascagoula Formation. And the Pascagoula Formation is what we kind of run into all the way to almost till we get to the coast, and these beautiful consolidated clay banks. These are claystone banks that make the walls of the steep walls of the river through here. And you can see another gravel bar kind of off in there. So the river is deeply incised through these stones of South Mississippi. All right, getting down into the coast. All right, I was telling you about the ancestral Pearl River. Well, there's the ancestral Pearl River that was blocked by this barrier bar. And sitting up on this terrace down here, you can see all these nice dunes and things like that. But this is kind of the ancestral Pearl, and not going back all that far ago. We're talking about just the last ice age and all the different environments and interactions between these coastal streams. You can see that Bay St. Louis is right there. It's the flooded mouth of the Pearl as sea levels rose into the old mouth of the Pearl, and then the Pearl River drains down, here, into its crow's foot or its distributary system as you reach the coast. All right, so this is where our estuaries are, and this is where the distributary systems of the Pearl would kind of branch out into the Gulf, and it shows you how complicated those environments are as well. All right, and that's pretty much it, the geology of the Pearl. Can I get any questions?
You mentioned the Ohio and the Pearl. Did they ever join them together?
No. The ancestral Tennessee-Ohio system was the Mississippi River before glaciation. So that was all that came through there. And it would have crossed the coastal plain a lot further east than the Mississippi does today. And so the Pearl probably was not even in existence during that time. It may have had some sort of drainage confluence draining the uplands, but not as we know it today.
The Ohio picked up the Mississippi.
The Tennessee-Ohio system did, as it still does. The Tennessee-Ohio system is part of the Mississippi River system. But going back in the older literature that had the Ohio River specifically confluencing, in the alluvial plain of the Mississippi River as far south as it did the geology doesn't back it up. It was something that was put out there years ago by early mappers, but the geology doesn't back it up. Questions? Yes.
You showed us what it used to look like.
Mm-hmm.
We know what it looks like now. What's its future?
Well, I guess that's up to everybody in this room, isn't it? I mean, how we conserve,
any projection on the way it's going now, what's it going to look like in 50 years?
Well, there's a couple things to go on here. As we modify drainages, as we clear land, as we channelize things, as we build dams, those are all going to affect drainages. That's how that works, and it's going to affect the ecology and everything else. One of the things that we're dealing with right now as far as sedimentation has to do with Ross Barnett itself. Anytime you build a dam across something, that actually becomes a sediment pond. And what that does is it starves the downstream from movement of sediment and the natural migration. So it ends up robbing its banks. And so you end up with a much wider, much shallower channel. And of course, that also is exacerbated with things that are done on the alluvial plain as far as riparian management. Where banks collapse and stuff like that, as far as farming or tree harvesting or anything like that. So that sedimentation, downstream like that, and it's robbing its banks upstream, makes a much shallower, much wider channel. And historically, people used to be able to take steamboats, which drafted pretty deep. all the way up, pass through here. And, in the summertime, you're lucky to get a John boat, over some of these low spots. So it has changed and it will continue to change, but like I said, it's up to us, to how we manage the system, what those outcomes are going to be.
This is I'm moving a little bit west, but you're saying they didn't have gravel bars until you got further down on Pearl.
Mm-hmm.
Over in Warren County on Big Black and Clear Creek,
Mm-hmm.
it's pretty good sized gravel through there. Where did that come from?
All right, that's actually coming from the ancestral Mississippi River as it was cutting down into its valley today. Those are our pre-Lurs terrace gravels. And yes, those are really big gravels, and because you're draining a glaciated region. Actually, some of the gravels that are from some of those gravel pits, we actually have on the front lawn over here. Those are ice-rafted boulders from the Ohio Valley system that came here some 700,000 years ago and rafted on giant pieces of ice. But we've got those sitting out front of the Natural Science Museum.
So is that only 700,000 years old?
Yes, that's when it got here.
Yeah.
Yeah, and those are from Ice Age floods. Probably, everybody's heard the Missoula floods, right? All right, what we had going on during the maximum extent of glaciation, which when the glaciers came all the way down as far as Missouri, the glacial floods that were coming down the Mississippi River through Mississippi at the time were far, far greater floods than the Missoula flood at the end of the last glaciation. And we know that from our ongoing geological mapping. Actually, Jonathan, who is not here today, is actually working on his PhD project, and he's actually answering questions for the written part of his dissertation on that very subject. So he would be here today answering that question if he weren't doing that right now. But that's our ongoing research. Yes.
Your core machine, how deep does that go to get a?
All right, our failing 1500 was designed to go 1500 feet when it was bought. Michael's 65.
Somewhere around there.
Yeah, Michael's was our former state geologist, but he sat behind that rig many years during his career as well. But it goes about 800 feet now. We're pushing it at 800 feet, but 1,500 feet is what it used to go. But it's on its like fifth or sixth truck, so yeah.
We saw about the above ground changing. Well, how about the aquifers? Will they change?
There are definitely going to be effects as far as aquifers, as far as how you change drainage systems, because the longer water can stand in an area, the more chances it has to percolate. But the geology also plays a big part in that. Clays are not, they don't transmit water well, what sands do. And so where you have a sand on sand interaction with the underlying geology with the alluvium, you're going to get either recharge or actually water feeding, either recharge the aquifer depending on the head of the aquifer, or you can actually get water actually feeding into the stream system where it's actually gaining flow. So, but as far as management, as far as effects, that really, it does play a part. Management does play a part.
Volcano, they look like the aquifer would also change.
Which is why we are getting our surface water from Ross Barnett, is because of the lack of shallow aquifers in this, adequate shallow aquifers in the area because of everything coming up over the dome like that. That it?
One more. How many tribs and how many dams?
I don't know that. Yeah, I mean, from little farm ponds on little ditches to major, it's probably a lot. But I mean, of course, the Ross Barnett is our largest major dam. But I also know that we actually have a few lowhead dams, like the one behind here. That I think there's a couple on the lower part of the Pearl. Paul, is that correct? One. Okay. So.
Well, no, two.